All right, let's get started. I'll start with a brief introduction about how we have previously done this call. We did one of this call last week, I believe. I'm preparing for my interviews, and I wanted to go a little bit beyond what is traditionally what we do, which is read books and then try it on our own. So I started using this tool called HelloPie. And what it does is it just basically asks you a question back and forth. But I wanted to also test my communication skills, and that's why I decided to host live sessions. I've done this in the past, maybe 3 years back, and there was some interest, so I decided to restart it. If you have any questions, I believe there is a Discord. I think the team from HelloPie is also here, so if you have any questions about them, you can feel free to ask them. But with that being said, let's get started on this one. What we are going to do is a presence indicator. And if you look at the Discord, I did post link to one of the talks that I found online. It's by LinkedIn themselves. It's an old one, but I think a lot of it stands true today as well, and I found it to be super helpful. So feel free to read into detail of they get into a lot of nitty-gritty stuff that we might not today. So here are the functional requirements. What we want to do is, if you don't know what presence indicator, it's essentially the chat that you see online, like if someone is online or offline or idle. So we want to build something similar to that. So user's status is updated, one-on-one messaging only, so no groups. Users can see the status of their connections, meaning I should be able to see if any of my connections are online or offline. And the non-functional requirements are real time. So you don't want to see someone online after like 5 minutes. You would rather see them online right away. Highly scalable. I believe this is what WhatsApp is. And then eventual consistency. Eventual consistency here. Why? Because I believe you don't want to it's okay if it is delayed by a few milliseconds or seconds. We don't want to see it right away. So with that being said, let's get started. What we'll do is I'll go over the high-level architecture. I'll draw and I'll explain my thought process. Again, if you have questions, please post them in Discord, and I'm happy to answer those. So how do we get started? Okay, so we'll have a client over here. The client will send, we'll probably have a load balancer, and we'll have a web server. So this is let's say if someone comes online, the request flows from client to load balancer and load balancer to web server. Let's assume we are not handling, I'm going to assume I'm not handling messages and stuff, and only the status itself. So we'll have a database, and the database will have status for now. Sorry, 1 second. Okay, and we can then the status gets updated. Status updated. One key thing here is that this will probably be a WebSocket. I'm assuming we can use the WebSocket that is used for messages as well. The WebSocket itself has 2 events. When something connects, you get a connect event, and when something disconnects, you get a disconnect event. So those could be our online and offline, and we can know that the user is online or the user is offline. You can have on the other side, we'll have, once the status is updated, you would have a queue, so a pops up queue. Queue. The pops up queue, I'm not going to get into detail of Kafka, but this could be something as simple as Redis. It doesn't have to be any more complex in my mind. And then you have a web server. So this is the other side of it, which is if I come online, then my connections can see me, online. So let's copy this. And this gets reversed. It would have been helpful if there was an easy way to do this, but okay. And the status is updated in the DB, and it's also pushed into PubSub, and then it gets propagated to all the other clients. There are a few gotchas here. One is, and I'm hoping we see it in scalability issues, but like, let's say it's fine if I have like only few hundred people on this, then this mechanism can work. But the problem happens when we have billions of people. So if I come online, we do not want to send this PubSub mechanism to everything. And I think we'll also have workers here, but we don't want to send this notification to every web server. You ideally want to send it only where my connections are there and only who are online. So I think that's the key to this entire problem. Like, how do you not send notification of someone online to everyone and just send it to few selected servers where the person's connections are online? So this would be workers. And the key to that is managing the map. Because you have WebSocket and you have this persistent connections, you do know that this client is connected to this web server, this client is connected to this web server, and you can manage that mapping somewhere. So this mapping would be somewhere like this. So you would have user to machine map. That way the workers can know, okay, this is where this person's connections are hosted. This is where all the network, all their friends are. And if I have only 10 friends online, then even if they're on only 10 servers, we are sending that notification only to 10 servers and not to like millions of servers that we have. So I would say like this would be my starting point. So let's say once we submit design, what do we get back? All right. Okay, so can you walk me through the data flow when the user status changes? And okay, so I'm just going to write exactly what we spoke about, which is going to be when user comes online, status is DB with WebSocket connection, connect event. We can change the status. The status change moves to PubSub, where the workers pick up the user's brand machine ID and propagate the notification. Okay, let's see what's the next question that it's asking. How would your system handle the sudden spike in status updates or notification to avoid overwhelming downstream components? I'm not sure which part of the component it is pointing at, but I'm assuming PubSub. PubSub is usually fine. You can actually just scale it pretty horizontally. You can just add more PubSub servers and be fine. I think web servers and load balancer are also okay because they would actually be limited by the persistent connections. So I would not have a lot of status changes unless there are too many clients connected. So I think the load would be on the workers. So like, let's say my workers are, I design my workers to process 1,000 status per second, and suddenly it increases to 10,000 status per second. I think that's where the problem would happen. Like the workers would not actually be able to handle that load, and what would consequently happen is that the status would get like delayed by latency. So we can horizontally scale the workers, which would handle the number of status changes. The DB can be sharded by the user ID. Okay, let's see if it likes that answer. Can you explain whether your clients use a push or pull model to receive status updates and why you chose that approach? Oh, the clients. So I'm assuming it's talking about this ones. So I think like it's actually a good question. We can do a pull model as well. This is more of a push model because when we the workers are pushing the status updates. If we were to do a pull model, let's think about this. How would this work? If it were a pull model, then the client would come online. The initial, when the client comes online, it would actually fetch all the users anyway. Like, oh, get me all my friends who are online, and it would send that. So that's your WebSocket connection. But then if I want to know every time, that's a lot of requests being sent to the database or even a cache in middle, which would say, hey, is my friend online? Is my friend online? And you're doing it for user online multiplied by friends who are online, which I think would increase substantial load on wherever that status is stored. Even if it is caching, you're just sending a lot of cache requests. So if you have like 2 billion users, I think like that's where the system would get a lot of, would be heavily constrained. So let's see if that's the answer it's looking for. It's a push model. If we go with pull model, then all the clients would have to consistently pull persistence to get the maybe. Okay, let's see if it accepts this answer. Okay, what mechanisms would you use to handle back pressure in PubSub or notification delivery pipeline? I'm not sure why it thinks there's a back pressure problem, because we said like we would scale the PubSub horizontally. So let me see if I can ask it more questions, because I don't quite understand. Where would the back pressure problem be? Because oh, what happened? Sorry, I think continue with 2 credits. Okay, there we go. We can horizontally scale the workers, which even with horizontally scaling, what happens if the rate of incoming status updates exceeds the rate at which the workers or the database can process them? How would you prevent message loss or system overload? Ooh, a tricky one. I know there is a question on the chat. I'll go to it in a moment. Well, let me just answer this flow. I think one thing we can do to prevent, we won't have a message loss, because the PubSub, I think we can, if you have a distributed queue, something like AWS, it automatically scales. There's no limit, unless you have your own machines and you're managing it yourself, you have an issue. But if you have managed solutions like distributed queue or Elasticsearch, which is provided by AWS, which is the Redis version, which is the Redis. I think, sorry, Elastic Cache. I think it would scale, but I do see the problem where the workers, like, we might increase it to, let's say, 10,000 statuses per minute or per second, and then suddenly it became 100,000. So I can see like it's kind of like playing a catch up. And I think like this is where like something like Kafka can help, because you can have like topic and partitions, and then partitions can have like you can have consumers, number of consumers scaled to the size of the partition. But I'm not going to change that entire thing, because it's I don't want to change the entire design. So let's try to answer this. We can use something like Elastic Cache, which scales for the PubSub regarding the workers. Let's see if it accepts it. If the system is persistently overloaded, how would you decide uh, which status updates to prioritize or drop? Let's hold up on that. I see some questions on the Discord, so let me go in and see if we can answer those. Um, Debating the merits of pull-up push model. Oh, how do you handle failures when you save status to DB but server crash before pops up? That's actually a pretty good question. If you have, if the, let's say I updated, uh, let's go to this diagram. So let's say we are over here and the status got updated on the DB, but the question is, what if it fails before you go to PubSub? There are two things we could do. Like we can, again, like this is not like a banking transaction where if something fails, we can have some sort of retry on that. The other option actually might be to have DB triggers. Now that sounds pretty easy, where you say, oh, if any row gets updated, push that into the PubSub, and like it acts as a trigger on that. But the problem with that is now it increases your load on the database. What you want your database to do is essentially it's either read heavy or write heavy. In this case, it probably will be more write heavy because all the push is happening in the PubSub. So I think like triggers might introduce a little bit more complexity, but I think triggers is one way to do it. The other way we can do it is, let's say I just connected to the client, to the web server, and it did not mark me online in the PubSub. We will have something like for idle, we will have to support some constant polling. And I'm assuming like as long as this socket is open, we'll keep polling to the PubSub saying that this connection is alive. And that's where like the workers on the other hand, or the client itself, can have some inbuilt logic, which it says, if the user is offline and they suddenly become idle, meaning they have transitioned from online to idle, which probably the message was dropped. So I think at that point, like we can have the client logic say that if it goes to idle, then this user is online, but we missed a message in between. So that could be something, but there's a delay in there because I could be, the idle logic might happen after like 2 or 3 minutes. So there might be a delay in that. The other option is like we can duplicate the messages. Like if we figure out a failure over here, then you handle that failure. But again, like for that, the system gets more complex because you have to now make sure that the DB and the status are in sync every time. Or you can also, like when the connection status is sent, and if this fails, you can send you can send another like HTTP 200. Instead of 200, you send like 500 or something. I hope that answers the question. I'm going to move forward with this. If the system is persistently overloaded, how would you decide which status updates to prioritize or drop? I don't think we had any priority in this, so I'm not sure why it's asking this. But But if we did have priority, then what we can do is we can have the workers actually do poll for like high priority first, or maybe split the queues. Again, this is where Kafka can come in, where you can have partitions based on priority, and each partition will have like different set of consumers, so that the ones with the priority do not just go away. But if we do, then we can have. Can you describe the flow for how the user fetches the present status of their friend when they open the app? The user connects. This is the same question that we initially spoke about. So the user connect. It would have been good like if this app was listening to me while I'm talking, so I don't have to type this over and over again. But something other feedback for the team. The user connects on the website. Let's see what it thinks about this. Are the friend statuses fetched from the database or a cache at connection time, and how are they kept up to date? I think we will definitely need a cache between this database. So let me update that. So this would be like a read through cache. For folks who don't know, in case if you don't know what read through cache is, it's essentially the first read when you're, because this is a, because we are reading the statuses, it would read in the database. If the database is reading the cache, if the cache entry is amiss, then it goes to the database and then it hydrates the cache at the same time. But when a write comes in, like let's say I was online and I suddenly went offline, now my cache is actually invalid. It still will show me as online. So what you want to do is during the write, you actually want to invalidate the cache and then go to make a write on the database. So my entry is now missing. And it will next read will update that status. We can read through cache, which is on of the rights. Is the source of. How do you coordinate cache validation across distributed web servers to ensure consistency at scale? I think I just explained that. I don't know why it's asking. Because it's every write replication. We can assume replication. How does your design handle eventual consistency and potential stillness for present status? I'm not sure why it keeps on asking me the same question. I think like with it being like a read through cache, it should and invalidation on every write. Like I don't think there would be any staleness. Why would cache invalidation in distributed systems can be delayed and lost due to network issues, causing temporary staleness. What would your approach be if invalidation messages are delayed or lost, and how would you handle such inconsistencies? That's a good question. I think we can invalidate on every subsequent writes. And if there are still inconsistencies, you can have you can have worker processes that would go and make sure that such invalidations do not happen. But these are again like one-off scenarios. I don't know if I would have something that maybe it runs as a scheduling job every now and then, but it wouldn't be something that's consistently running. So let's try to answer that question. So if you want to take care of the stale cache, usually in my experience, what we have done is you either just nuke off the entire cache. Like let's say we figured out this region has some issue with the cache, or this region was facing, like you can look at your operational charts and see some spikes. The easiest way to do that is to nuke off the cache in that area. It could be by region, it could be by certain user ID. Let's say I have a bug where certain users are getting impacted. So this would be like kind of like a one-time thing that you do where you nuke off the cache. And since our database is always going to be the source of truth, we rely on the first read might all fall onto the database. And I think it's going to probably ask me the question, like, how would you handle this scale on the database as well? So let's see if it goes in that direction. And if it does, then we can, again, this is more of like this becomes like a incident management issue as opposed to like your runtime. You would just have your database take the load initially. You would scale it up, take the load, and then scale it down again. So we can Okay, so this concluded the high-level architecture. It went way deeper than high-level architecture, but I think there are some questions. Oh, no questions. Okay. Let's move on. What happened? I don't think it's going to the next section. Ah, there we go. Okay, so this seems to be like data model. So if you guys remember, we had DB statuses over here, and we had sorry, 1 second, please. All right, so we had DB statuses over here, and we had user to machine maps. So I think we need to create the entities for those. So let's say status, and then my primary key would be user ID. I don't know, int maybe, or long int, big int, I guess, big int. And we would have status, which would be int. In this case, I would have 0 as offline, 1 as online, and 2 as idle. What else? And you would have entity machine info. So this would be user ID, reference of. This also would be reference user. So there would be like a user table somewhere. I'm not going to, this would be kind of like a foreign key relationship. And then you would have machine ID. And then, I don't know, big machine info, I guess. All right. Let's see what it thinks about this. Let me clarify the primary keys for each entity and how machine info relates to the status. So how would you handle users with multiple devices? So users with multiple devices actually doesn't matter, because in the status we have user, and user is either online or offline. It doesn't matter where the user is online. The thing that would matter though is actually a user might be connected. If I'm online on two devices, then I have I have two WebSocket connections from each of my device. So it actually is correct. Like I would need a device ID somewhere here. Device ID, uh, ID of the device, and this would be my primary key. And this would be my primary key. The reason I would have user as a primary key is because one user might be connected to multiple different, multiple users might be connected to one machine, but it's also very likely that multiple uh, machines might have the same user, because now we have device ID. So actually, this might be our primary key. And user ID would just be a reference or a foreign key. But we would also need index on this, like a secondary index, because my query would be something like, give me all the machines where this user is present, is connected. Because remember, if you guys remember, in this case, we were sending notification from the workers, and the workers query would be, for this user, give me all the friends, and for this friends, like let me know where they are connected, and that's where we'll send the notification. So this is where the machine info and status would come into picture. Let's see what it thinks now. If a user is logged in from multiple devices, how will you represent and update the status? The status need not be per device. We can just add status by user. Can be Can you explain the purpose of machine info entity in your data model and how it will be used? The machine info is machine info basically stores the location of which user is connected to which machine. What database type would you use for storing the user status and why? I think SQL is best. I don't see the reason to have like NoSQL. I guess we could also have NoSQL because it's only storing statuses. So we could have something like a NoSQL database. Let's think through this. If I did have, I'm assuming this is like a chat application, and the user's information, if we were to have user and their friends, that would probably be a SQL database, because you want to store relationship between the user and their friends. Now, the status itself can be a NoSQL database, but then we would not have the foreign key relationship. So there are pros and cons to this. Uh, NoSQL databases are much faster, especially on like if we use like log structure merge LSN trees or something like that. It would be able to append only the status, and the writes can be really fast. So I guess I would still go with SQL, just so that like everything is in SQL database for now. Um, let's see if it likes the answer. Well, a trade-off between SQL and especially considering scalability and real-time updates. One thing about SQL in this case is we're not just very specifically for statuses. We're not using like the ACID properties that SQL usually provides. So like transactions or anything. So it might be, and it might not be the best to use a SQL. Maybe we can go with NoSQL. Let me answer this more diplomatically without saying I'm wrong. So NoSQL can be. That was our main reason. That was my main reason for picking SQL, because I assume like everything else is also SQL. Yeah, if I was just building like the status, just this system by itself, then NoSQL might actually be a good choice. Is machine info required for core presence indicator function, or is it used for notification routing? How would you keep machine info and status in sync if needed be? I don't understand why there would be a need to keep them in sync. I just need to know if the user is connected or not. There's no reason. I don't see the status and machine info to be in sync. So I'm going to respond with that. It is used. Let's see if it can clarify why. How would you handle expiring? Okay, it did not really tell me why it needed that answer. So I'm assuming it accepted my answer. How would you handle expiring or updating a user's status if they disconnect unexpectedly or go idle? So this is where the notification, the WebSockets disconnect event comes into picture. So let's say I'm on my phone, I'm online, I go through a tunnel. Suddenly my network is gone. I got disconnected. That's when like I do know on the server side, the WebSocket would give you a disconnect event, and that event is what we can use to know that the user has gone offline. The idle part, on the other hand, we can, if we go to this high-level architecture, let me see if I can zoom in a little bit. The idle part, we will have to, the same WebSocket will probably be used for sending the messages back and forth, not status, but like if you're typing, and you send a message or you receive a message, we can use the same socket connection. So the same infra can be used for that. And that when that message is coming back and forth, we can know you're idle, a user is idle or not. So let me answer it by saying, how would you ensure that the status in the database is updated reliably in case of network partitions or delayed disconnect events? I don't think the delayed disconnect events would actually matter as much because, again, we are not doing a banking transaction or we don't need like real time. One of the non-functional requirements is to have real-time updates, but again, these are this network partitions and delayed disconnect events would not happen to most people. So we would have some SLAs, and I think if we're as long as we are meeting SLAs, these are like one-off cases that might happen. In which case, I think we can just take it as a trade-off that based on the system we have, we can there will be such delays in the system. As long as it's meeting the SLA, I think that's how I would answer it. I don't think there is a way to like solve all the problems. Usually in system design, that's how I approach it. You give the trade-off, you let the interviewer know that, hey, this is the trade-off that I think is, and we have considered it, and then you just make sure your system lets you know when such an event happens. So I would just say, no, it accepted the answer. Okay, I think this is the last section of deep dives. I think it's probably going to go into the notification. Oh, I just wanted to remind you guys one thing. Like on this website, they actually will make this particular interview public, so you can go and read it later on. And sometimes they also generate bunch of text or sorry, explanations around actually what everything that we discussed. So if you guys are interested, you can go and check it out on the website, or someone from their team can share it. Let's start by discussing how status updates will be propagated clients with billions of. Imagine a scenario where the user status changes frequently. What approaches would you use to ensure that all clients? So it would. I think the answer would be same. I'm just going to describe the flow that we had, and until it tells me like there's a gap in this particular section or this answer. So. So like I said, this is a very similar system to what LinkedIn is using. So again, if you have, they go on that particular thread, they go more into like Akka, and if you guys know those frameworks. But if you're interested, take a look. It's a very short video, like 30 minutes, but it's actually quite, it's very interesting. And they talk about a lot of problems. They actually talk about problems at geo scale as opposed to like we just dealing with just raw numbers, and how they actually made sure that the notifications go only to a very specific data center or a zone where your users, your friends are connected, and not just randomly going to like different servers. You describe PubSub and worker-based approach. Let's dive deeper. What are the trade-offs between using WebSocket, long polling, and server-sent events for delivering the real-time presence updates to client, especially events? So this is where it goes into Akka. I remember like in that specific talk, they said that they tested out, they took some machine and they tested out like how many threads does Akka support. And it came out to be like 100,000 plus connections it was able to support on one machine. The machine was pretty beefy. It wasn't like a very small machine or something, but that's also like it's 100,000 connection is a lot. So if you have 2 billion users, then you're talking about maybe 10,000 machines, which doesn't seem as, and we do have to, and also one more thing to know, like this is not just used for status updates. We are also using the same infrastructure for sending messages. So it's serving multiple purposes. It can also be something like, if you guys know, like when you type on Instagram, or if you're chatting with someone, you can see this person is typing, or this person in Slack. And again, it's the same infrastructure, same WebSocket that you're using to send these messages back and forth. So I'm just going to write like this. It can like the servers will get exhausted. Like there's only so many connections you can support. Let's focus on the scalability. With billions of users, how would you scale your WebSocket infrastructure to support that many concurrent connections? I'm just going to explain what I just explained with like we could. There are also different ways. In one of the projects that I worked in, we saw spikes in different regions. So, for instance, like we had a lot of users in Japan as opposed to in US. So and it was also during a very specific time. So we had our scalings done in a way that during the day when it is night here, but day in Japan, the number of servers or machines in Japan would increase dramatically, and the number of machines would go down significantly in the US. So there's also like regions that you have to take care about. But let's see if it goes in that direction. Provisioning is a good start, but with billions users, sharding and routing becomes critical. How would you shard or partition users' connection? Oh, yeah, this is a good question. So you don't want to, it actually picked it up. And this is something that the folks in LinkedIn also mentioned, that you want to, you don't want to send it to like a random WebSocket or a random machine. You want to shard your machines also by user ID. So let's say I have 10,000, and I think the way they did it is something like consistent hashing. So they would hash the user ID, and they would find out like a set of like 10 machines or 15 machines where the user might go, and then they would just pick, and then they would leave it up to load balancer to pick one of those machines. So. The sharding by user ID is common approach. However, in real world scenarios, some shards might become overloaded. So I think it's talking about hot shards. That's an interesting question. I'm not sure how, if we have sharding and if we have a hot shard. You can horizontally scale that shard. That's one option, but I don't think it's looking for that. You can, I think you can have something like consistent hashing is one that we would have. So we can add like more servers and more shards, which would essentially like move the users. Now there's a, there is a caveat to this. So like, let's say we have like 5 shards, just to take an example. And one of the shard, like let's say shard number 4 is becoming a hot shard where it's not able to handle the load. So we can horizontally scale it by adding more machines. But again, when you add more machines or when we add more shards, the users are going to move it based on consistent hashing. They're going to move into like a different machine at that point, and there might be a disconnect that might happen. So the user will lose a connection, but the client can, the moment the client loses the connection and the user has the app open, the client can retry to make a connection and they will go to the next shard. So, and that's where like the status changes might be a lot. Like if you guys remember, initially it asked like, what if there's like an influx of statuses? So this is the place where that might happen. So let's answer that question. You can use similar to consistent hashing. Okay. See what it says about that. But user migration can cause brief disconnect. Exactly. How would you minimize disruption and ensure presence updates are not lost when the users are migrated? I don't know why it's asking about data loss. I don't see any data loss. I think once you disconnect, if you're sending a message, that message is just lost and the client will have to retry. So our phones have memory in them, even the client-side memory. So it's always storing those information, and you will see like a message like, oh, failed to send, and then you tap to retry, or it retries on its own. It depends. Like the iMessage, I know, like forces you to retry, versus WhatsApp or Instagram will just send it on its own whenever the connection is established. So I don't think there's like a data loss in my mind. I'll try to probe it, but the disconnect is going to happen. Just just one more thing. It's a 2-minute warning. I will, even though this does not end, I'm going to end it. So maybe this is the last question that I will answer. If I send a message and there's one more thing that comes to my mind is like if there is a lot of disconnect and reconnect happening, and which if you have 2 billion users, like it is bound to happen. This changes our design a little bit. But the problem I'm trying to expand on is if the users are connecting and disconnecting, reconnecting every time, you don't want to overload the system for the status. It's also very jarring for the user on the, like if I see a person coming online and offline and online and offline. So there's one way to control it on the client, but a better way would be that we control it somewhere over here, where if the user has gone offline, it's marked as offline. We have like a status update, like when the status updated, and only if a certain amount has passed, that's when we say that the user is offline, maybe like 30 seconds or a minute or something like that. So that way the system is, we don't overload the system and also the client experience. So we don't see people going online and offline every time. It depends on certain cases. Like I know Slack does it pretty much real time. Like as soon as someone goes offline, it shows it offline and then online, because it's more of a workplace chat system where that information is probably important. But that's pretty much it. I hope you all enjoyed it. We'll probably do one more session or maybe a few more next week. If you're interested, if you liked it, or if you have any feedback, please drop a note on Discord. If you have any questions, happy to answer those as well. But thank you very much for joining on a Sunday. Have a great rest of your weekend. Bye-bye.